All right, so I kind of combined lessons 9.4 and 9.5 together because they both talk about trig functions, but they talk about them separately, and I like to talk about them and teach them a little bit differently. So first I like to just focus on, well, what is a trig ratio? Figuring that out, and then using them to solve for side lengths. So that's what we're going to discuss in this first video. Then in the second part, I'm going to show you how to use them to find missing angles. So initially, just like Pythagorean theorem, how we solve for missing sides, we can do the same thing with trig. Now, a trig ratio relates the sides of a right triangle to its angles. So now we're tying them together, where the Pythagorean theorem was just relating those three sides. We're wrapping in the angles to part of this. Now, the opposite side is the side, now I know, right? Opposite of the angle of reference. It goes against like everything that your English teachers have probably ever told you when defining something. But really, so this little theta guy here, that is my angle of reference. So the side opposite of it would be MN. The adjacent side is the side, get it? Adjacent. Or we can say next to if that really bothers you, using the exact same words again. So adjacent or next to that angle of reference. Now, again, here's my angle of reference. I have had questions in class before saying, well, what about LN? And I'm like, you guys, LN's not a leg, that's a hypotenuse. Okay, so LM is my only option. That would be the adjacent side, because the last one here, the hypotenuse, is always the side across from or opposite of the right angle. So hypotenuse, we already established that in lesson 9.1. Now, the sine is always these two together. Now, I want you to write these three trig functions down, or find something online and print them all, because we are going to be referring to them a lot. Now, let's take a look at how I would write these. I'm just going to make up some numbers. 3, 4, 5, okay? Because I know that those are correct. The sine here would be, so this is my angle of reference. The sine of this angle is the opposite. Well, opposite is 4. So it would be 4 over hypotenuse. Hypotenuse is 5 because it is the side opposite of the right angle. And that's literally what I'm asking for, is a ratio of the sides. The cosine is a different set. Instead of the opposite, we have adjacent over hypotenuse. And then the tangent of an angle is just the two legs. We're not even worrying about the hypotenuse. Now, maybe you're a little bit confused right now. Let's practice a few, and hopefully that'll clarify things. Okay, I want the sine ratio. All right, so what is the sine of angle A? That means A is my point of reference. Now, instead of writing out sine, S-I-N-E, we can abbreviate, and this is what it looks like on your calculator. Okay, so the sine of angle A is, well, if you refer back to that sheet that you just wrote down on, sine is opposite over hypotenuse. I'm going to write that up here. Sine opposite over hypotenuse, okay? Well, opposite of angle A, like picture yourself, shrunk way down, you're standing here at angle A. What is opposite, which side is opposite of angle A? Well, it would be side 6, right? Over the hypotenuse. Well, which of the sides is the hypotenuse? I hope you said 10, because it's the longest side. If you did, you'd be right. Now, the only other thing that we can do here, we're almost done. 6/10 is a fraction that can be reduced. Both 6 and 10 are divisible by 2, so I'm going to go ahead and do that. 3/5 would be my most reduced ratio. All right. If you really think about just shrinking yourself down and asking yourself and looking at those words, the opposite, adjacent, and hypotenuse, you're going to be able to sort this all out, and you're going to see why we use this. It's not just to write a fraction down for fun. It's to actually help figure some other stuff out. Now, let's take a look at the next one. What is the tangent ratio for angle A? So again, angle A is my point of reference. That's theta, just a Greek letter that we use for angles. Okay, so tangent can be abbreviated as well. So the tangent of angle A, or tangent of theta, however you want to mark it, is equal to. Now, tangent, look back at your sheet. Tangent is what over what? Opposite over adjacent. So my opposite side is 6 over my adjacent side is 8. Okay, then we can reduce it. 6/8 reduces to 3/4. So that is the simplified ratio that I'm going for. All right, now I'm going to ask you to think a little differently right now. So now instead of giving you the angle and then you figuring out the fraction, you have the fraction. You have the ratio. You got to figure out what angle I'm talking about. So cosine, if you look at that reference sheet, cosine is adjacent over hypotenuse. So if I'm doing the cosine of some angle, when is 8 adjacent and 10 the hypotenuse? Well, 10 is always the hypotenuse, right? But at what angle must I be standing at for 8 to be the adjacent number? It's going to have to be A, right? A would be where 8 is adjacent. C, 6 is adjacent, so that's not it. And angle B is a right angle, so we're not going to look for that angle. And then I would have 2 adjacent legs. So the right angle is out. Angle A here is when my ratio is 8/10. Okay, pause the video and figure out which angle you have to be standing at for the sine ratio to be 8/10. Okay, sine is opposite over hypotenuse. I know my notation's getting even shorter. So opposite has to be 8. Well, what is opposite of 8? Angle C, and then 10 is still the hypotenuse. All right, now let's talk about what are we actually using this for. We are using this to solve for side lengths. I am looking for side DF. That's given. So I'm going to put an X here just to kind of mark the spot that I'm looking for. Now, since I know angle D is 65 degrees, what is side DF in comparison to that angle? Well, it would be the adjacent side. It's right next to it, and 8 is the hypotenuse. Okay, so go look at the 3 trig functions. Which one uses both the adjacent and the hypotenuse? I hope you said cosine, right? Because cosine is the only one that has both of them. So the cosine of an angle, in this case our angle is 65 degrees, is equal to the adjacent, which is x, over the hypotenuse. When you solve these, you have to sort out which of the 3 trig functions you're going to use. All right, now I need to solve for the value of x. So this is where we have to do some algebra. To get x by itself, currently x is divided by 8. The inverse operation would be to multiply both sides by 8. So I have x is equal to 8 times the cosine of 65. Okay, when you type it into your calculator, I put a calculator over here. You're literally going to type 8, so hit that button first. And then you can put times right next to the cosine because it's going to multiply. So 8 times cosine, and when you type in cosine, so your calculator is going to look something like this, okay? When you type in cosine, it'll pop up automatically with one part of the parentheses. So that is saying cosine is of this angle. So that angle goes in there, and then you can close the angle or not. I would encourage you to just get in the habit of closing it because later when our equations get a little more complex, you'll see why that's important. Okay, so 8 times cosine of 65, and we get approximately 3 3/38. So x is approximately 3 3/38. Oops, we got to hit equal on our calculator. Okay, and it keeps going on, but I'm just going to round to the nearest hundredth. So that is telling us that this side length is about 3 3/38, which is reasonable if the hypotenuse is 8. Okay. If you do it on Desmos, you can do the same exact thing here. We would do 8 and then times the cosine, and then you would type in 65 because that was our angle that we had. And you can see that down here. I actually screenshotted what it looks like typed in, because I know that not all of you might have a graphing calculator at home. So instead, just go ahead and log on and use Desmos, because it does the exact same thing. All right, and I chose the Desmos Scientific, not Desmos Graphing. Just a little FYI for you. Okay, and then on big ideas, when you do your homework, you should be able to, the calculator should just pop up for you. All right, now let's take a look at another one. We are looking for the side length MN. Here's MN. I don't know it, so I'm going to put an X there. It's just my placeholder, helps me figure out what I need. Okay, now if I'm standing here at 23 degrees, X is the hypotenuse, 14 is the adjacent, right? I have to use that because I'm given 14 and I don't know X. So hypotenuse and adjacent are the ones that I am going to use. So let's write it out. Hypotenuse and adjacent, which trig ratio is that? Hopefully we got cosine, right? So cosine of the angle, 23 degrees here, is equal to adjacent, which is 14, over hypotenuse. Okay, this one's a little more complicated because you'll notice that X is in the denominator. So how do I get X out of the denominator? Well, I'm going to multiply by X. Perfect, I've got X times cosine of 23 equals 14. But this is an issue because X is not isolated. It's not by itself. So I got to finish out this equation. To get X by itself, it's currently multiplying by cosine of 23. So I divide both sides, yes, you can do that, by cosine of 23. Not just 23. You have to take the function cosine of 23 with you. So when you type this into your calculator, it'll be 14 divided by cosine, and then again that parenthesis automatically pops up, 23, and then close up that parenthesis. All right, now here's what it looks like on Desmos. If you type in 14 and then divided by, cosine will be a function on there, and then it'll pop up with a parenthesis just like your calculator would. You type in 23, and then you can arrow over to end that parenthesis, or you can click the parenthesis, either way. But when we do that, we can see this is our answer. So we get approximately 15 and 21/100ths, about, rounding it. Okay? So that would be the side length of the hypotenuse, about 15, which makes sense because the longest leg is 14, so it's definitely going to have to be more than 14, but it doesn't look too terribly much longer. I know this is a lot of information, but I want you to pause right now and try these two on your own. All right, in that first one, I'm looking for MO. I have the adjacent, which is 28, and MO is the opposite. So the trig function I'm going to use, which one has both opposite and adjacent, that is tangent. So tangent of 16 equals, and tangent is opposite over adjacent, so x over 28. And then at this point, it just becomes algebra. Multiply both sides by 28, because currently we're taking x divided by 28. And then we have x is equal to, go ahead, type that into your calculator, 28 times tangent of 16. We get approximately 8 3/300. So 8 3/300. I have 8.02887 and it keeps going on. But if I round it, that's what I get. So my short leg we're saying here is approximately 8. All right, again, pause, do the second one. All right, so looking for QU here. QU would be the hypotenuse. 30 is opposite of that angle 51. So which trig function has opposite and hypotenuse? That would be sine. So sine of 51 is equal to opposite 30 over my hypotenuse, which is x. I don't know it. And now we do a little bit of algebra. So to get x out of the denominator, multiply both sides by x. And by doing so, we still don't have x quite by itself, so I need to isolate x. It's currently being multiplied by sine of 51, so divide both sides by sine of 51. And at this point, we have x is equal to 30 divided by sine of 51. And you can type that into your calculator just like that, 30 divided by sine of 51, and we get approximately, rounding to the nearest hundredth, 38 6/10 actually. All right, we're going to go ahead and pause here. This is how you find missing side lengths using trig functions.